Good afternoon. This is Frank Marisick, President of EE Reports, and I'd like to welcome everyone to our Advanced Multipoint Submetering Opportunities webinar presented by Triacta Power Solutions. Although the webcast is focused on the enormous New York market, you will be able to apply the many Triacta Multipoint benefits just about everywhere. Throughout the world, energy is being transformed from an unavoidable cost of doing business to an asset to be managed. In fact, research done by NYSERDA estimates that installing submeters in master meter buildings can reduce consumption by 18 to 26% alone. Submetering is the crucial component of energy management for attaining granular energy use data and the gateway for other software and services to generate actionable insights. In addition, a number of important regulations such as building codes and mandates like New York City's Local Law 88 are coming into effect, requiring submetering or continuous energy monitoring. To get an idea of the potential market growth, a recent report from Navigant Research predicted global revenues from electric submeters to almost triple from $950 million in 2015 to $2.5 billion by 2024. So now that the need and demand has clearly been established, the question you should be asking is, what submeter do you choose for your building or customers? You want a submeter that bridges the gap between building automation and the Internet of Things. A smart, scalable networking device that is future-proof by design. Triacta Power Solutions designs and manufactures high-end, revenue-grade energy management meters for multi-unit commercial, institutional, and residential applications. And here to tell us how to take advantage of their advanced multi-point submeters in New York and beyond is Gord Eklund, Vice President of Marketing and Sales for Triacta.
Thanks, Frank, and thank you everyone for joining us on what is likely a vacation week for most. As Frank mentioned, let me start out by focusing in on the state of affairs that is sparking our interest in metering platforms today, or at least why I think people have called in to listen. The rising cost of energy continues to be a key issue for property managers, tenants, municipalities, and utilities. As a result, over the past 20 years, new energy management concepts and language are coming forward into our daily conversation. There's a veritable word salad of concepts that have popped into the vocabulary of anybody who has anything to do with electricity today. This word salad, terms such as price signal and negawatts, represent systems, programs, and regulations that have been building over the past 20 years to help us manage our spendthrift behavior with energy, while we transition to new energy sources and generation. It's nice to imagine a world awash in new fossil fuel resources, with the U.S. as a primary exporter and energy power as a result of fracking technology. But we all know that we need to work on a cleaner and more sustainable future. The long-term solution is the development of new sources of clean energy, and governments and business are busy working towards that end. But the near-term solution is not new energy sources, but negawatts, or the lack of consumption, refraining from using energy where possible, and refraining from building the wrong type of energy generation. The philosophy of negawatts is where today's opportunity for building owners and building professionals lies. The best tools for creating negawatts are user pay and the price signal, making the consumer of energy accountable for their own consumption. There is a catch, though. You need to be able to attribute consumption to the right parties, accurately and traceably, and you need to be able to understand the nature of overall building consumption to be able to change habits and processes. The tool for that is the simple electrical meter, put to better use. Why? We live in a world where new buildings can be built from scratch, incorporating the latest technologies. But we also live in a world where most of the existing building fleet does not have adequate technology installed to accomplish the job at hand. Real-time information and analysis. There's a massive requirement to retrofit buildings to make this happen, but the retrofit path is fraught with high costs and potential technology missteps that don't deliver the goods cost effectively. Fortunately, among the choices of doing nothing, using antiquated tools, or pursuing expensive and overly featured building automation tools, a lightweight overlay solution has emerged that effectively addresses the issue. Networked multipoint meters. The multipoint meter solution is purpose-built to address retrofit applications. It is designed to be cost-effective. It is designed to look deeply into the electrical network of a building and query electrical use. At the circuit level, as opposed to the black box overall building consumption level, which many older buildings find themselves stuck with today, with only the utility bulk meter to monitor consumption. The network meter solution has been deployed extensively and proven to be effective. It is available today at a relatively low cost, especially compared to comprehensive building automation systems that need wholesale change in the building. We know it is deployed, for instance, in the Hearst Tower, in the Sterrett-Lehigh building, and in Rockefeller Center. Still, even with this proven track record, multipoint meters are still poorly utilized by facility managers and property owners when left to their own discretion. But this is beginning to change. Regulations are key, and they are starting to happen. New laws, such as New York City Local Law 88 and California Building Code Title 24, Part 11, are now specifying the use of meters to facilitate the conservation of energy. Here is the good news for anybody thinking about gaining an advantage by getting smart about multipoint meters. It's still early days, and there is a first mover opportunity for companies that are aware of the impending market shift and establish themselves as competent, if not expert, in the networked multipoint metering solutions available. These solutions are not all created equally, and some are better at fitting into this new energy environment than others. An environment which requires communications protocols, open systems compatibility, and fluid information flow. What are the key characteristics to look for? Electricity management requires IT-centric metering platforms and energy management software to fulfill the promise of the price signal effectively. Energy management software vendors and property managers need reliable, easy-to-deploy metering systems as the foundation for their businesses. Metering platforms must match the information technology sophistication of building automation, but be simple and easy to deploy. In the electrical domain, the electrical contractor is ultimately the key to deploying these systems, and must be competent in using them, literally a move to incorporate a technician role. This is a new role, and few electrical contractors are competent enough in these new systems or even see the requirement/market emerging, and many are just plain afraid. But there lies the opportunity. The door of opportunity is open for electrical contractors, system integrators, and energy management companies, including the traditional ESCO, who want to aggressively seize the moment, to be subject matter experts in providing solid, reliable, IT-capable metering platforms. So what is this opportunity? For electrical contractors, the opportunity is that they can win business that requires more than just a spot meter here or there. They can open up the door of value-added service potential and stickiness with their customers and partners. Niche expertise in meter deployment opens the door to new opportunities, as one of our partners, the State Group, has determined. In their estimation, for every dollar they receive in meter deployment, they receive $4 in other work. For energy management software vendors, the opportunity is to take the problem of obtaining accurate and granular data from old, existing meters in a building out of the risk equation by ensuring the right metering fabric is put in place. That is, a meter fabric with advanced IT characteristics that they know how to manage and can rely on. For energy service companies, ESCOs, the opportunity is to go beyond rule of thumb estimations historically used by using real-time accurate measurement instruments. There is also the opportunity to get bonus points for establishing an open, unambiguous, real-time measuring system for their clients. For system integrators, be able to branch into the adjacent market of electricity where there is currently a vacuum from the building automation world. For owners and property managers, the overall opportunity is to ensure that whatever project they pursue, they acquire a long-lived, future-proofed building information asset that can be employed by multiple stakeholders and any external service provider they may choose in the future, thus avoiding lock-in. Vendors may like lock-in, but owners don't. Vendors should be giving their customers what they want. So, why is Triacta a good choice when you are considering a networked multipoint platform? To fit into the new electricity world and be a useful product, we have learned a few things about the basic requirements. The new electricity world is about ecosystem-wide data visibility. It's about easy to deploy, cost-effective, granular metering fabrics. It's about reliable, long-term operation. It's about the ability to fluidly direct information to any service provider through open systems that avoid lock-in services. It's about standards compatibility and regulatory compliance. When dollars are involved, an instrument of weights and measures standards is required. And it's also about looking beyond a single building footprint to entire property fleets. How does the PowerHawk platform address these points? Number 1, deployment. It is one thing to walk in and install a manually read single-point meter on a panel or in a suite. It is a different level of complexity, though, installing a multi-point system in a brand new building, never mind a retrofit situation. This is the point of highest pain in the project. Do this incorrectly, and it affects all the results. PowerHawk meters are designed to easily integrate with existing electrical panels. Current transformers, or CTs, are the link between in-panel breakers and meter point inputs via color-coded cabling that ensures easy matching between the meter and what is required to be measured. By using accurate single-line drawings or making a site visit, the electrical system of a building can be modeled with the PowerHawk Manager's hierarchical representation tool, which matches meters to panels, services, and physical building characteristics. The cloud-based PowerHawk Manager generates an installation record for the contractor to wire into the panel, using color coding for proper circuit association. Once the CTs are wired, the contractor simply plugs the cable into the meter. The installation record also serves as a permanent record, both in the database as well as affixed to the electrical panel, for traceability and, if required, future troubleshooting or moves, adds, and changes. Modeling the design in the PowerHawk Manager Also allows meter configurations to be downloaded into the meter at time of installation, when communication to the internet is established and the meter automatically homes back to the PowerHawk manager. This saves any on-site programming. For the deployment process, communication with the meters is also simple, utilizing existing building automation protocols or a simple local area network, wireless or wired, connection directly to the internet, sending information to the PowerHawk manager or server of choice. More on this later. In deployment, commissioning of meters is also a point of pain. Ensuring that they are connected properly, measuring correctly, and associated with the right circuits. PowerHawk meters and their networking capabilities provide tools to expedite commissioning. This is the web page right from the meter, which can be reviewed from right beside the load, ensuring connectivity on a tablet or mobile PC. Commissioning can be performed by direct manipulation of loads while viewing the effects on the meter in real time, remote from the meter in the electrical closet. Number 2 characteristic, reliability. Reliability in this choice is of high importance and an often overlooked criteria for when choosing a multipoint meter. Buildings are built for decades of use, and an installed metering platform should be too. This is not arrived at by quickly designing a meter, despite the availability of meter chipsets. PowerHawk meters are designed with high reliability in mind, not only in terms of mean time before failure, which is as high as any traditional simple bulk meter, but also in terms of measurement accuracy. Triacta meters maintain calibration for at least 10 years without an issue, and have to, in order to comply with some regulatory regimes that we operate in. Characteristic 3, communication standards. Given the mandate of visibility of information, communications to the meter is a key consideration. For decades, submeters, single point or multipoint, have relied on older communication methodologies to collect information. Typically, this has taken the form of an RS-485 interface leading back to a proprietary collector, using proprietary communication standards. So difficult to use, it often ends up that the facility manager just goes back to the manual reading of the meters, and ultimately the system will likely fall into disuse. A slightly better scenario is the use of the Modbus protocol over RS-485, which allows for the use of third-party data collectors. This approach allows for some flexibility. The collector may have better usability and wider application than metering, but still requires an on-premise collector that pools information in a manner that is typically only accessible locally on the facility manager's personal computer. Fast forward to today. Much is being made lately of the convergence in the intelligent building, with a common IP or Internet protocol backbone acting as an information superhighway up and down the building. This approach has a strong acceleration effect on information visibility and flexibility, promoting many systems using the common communication highway. It also creates one very short hop to making information available to the Internet itself, and being able to make the information available globally to many parties. All that needs to happen is having the local area network connect to the Internet. Despite this type of breakthrough, it is still common practice to make meters slave to collector boxes that pull the meters, even when Internet protocol is used, by using protocols such as Modbus TCP/IP and BACnet IP. This adds more complexity to the deployment and creates one more opportunity for vendor solution lock-in. PowerHawk meters, on the other hand, can support Modbus RS-485 interface communication simultaneous with Ethernet IP connection. Further, on the IP side, the PowerHawk meter can be a slave to multiple building automation system masters using Modbus TCP/IP or BACnet IP protocols. As an aside, this is still the traditional collector architecture. But more importantly, PowerHawk meters connect directly to the cloud, essentially as an Internet of Things participant. It is a real bridge between the traditional BAS and IoT worlds. You can have both. PowerHawk meters can immediately, upon LAN connection, report to the PowerHawk Manager cloud server or any other energy management server or dashboard. And this reporting can take place while the meter is also being queried by any number of on-premise building automation systems, making meter data available any way that it is needed. Characteristic 4 is management. The critical piece in transforming electronic devices from a group of one-offs to a platform is management. Most metering systems use a client-server style of management system, installed on an on-premises local server, communicating to the meter via Modbus RTU. Programming of the meters are almost exclusively performed locally at time of installation via direct RS-232 connection from a mobile PC. Some companies are moving to a manager of managers architecture where a cloud-based application can talk to the on-premise manager to give non-local visibility. This is typically still an afterthought band-aid. The PowerHawk Manager communicates directly with meters via Internet Protocol and performs the following tasks. Number 1, it creates a hierarchical representation of the meter network, which can view the meter points from many different perspectives. Building physical, view by payee, or view by a services orientation. Number 2, the PowerHawk Manager provides user accounts at any point in the hierarchy, with scope of control and visibility limited to all branches below. This enables expanded visibility while maintaining security, privacy, and control. For instance, this would be a typical scope viewed from an account that is being limited to 2 buildings, representing a property manager's view. And here is the account management tool that works in a similar hierarchical manner to the building view, with a metered company account and individual accounts below that see different parts of the tree. Number 3, PowerHawk Manager allows for remote programming of meters so they can be shipped directly on site. As shown in our section on deployment, this is the cloud representation of a meter programming panel, which appears when opening a meter icon on the PowerHawk Manager. It mirrors the look and feel of the local configuration tool that would be used with a meter locally. Number 4, PowerHawk Manager provides a comprehensive set of meter diagnostics for monitoring meter network health. For instance, these diagnostic panels show active metering points, meters that have not reported, or meters with outages, lost power. Number 5, PowerHawk Manager establishes a meter network billing asset, management and topology that can be exported or imported via XML for interaction with other dashboard and energy management applications. This is just a snippet of such a file. If you look closely, you can see the code is a language-based version of the graphical tree it was exported from, including all meter, building, and electrical panel information. Using this facility, the PowerHawk Manager can be used in conjunction with the dashboard and energy management software partners we work with, allowing the creation of the meter hierarchy in multiple applications. PowerHawk provides graphical representations of voltage, power, current, and reactive power, important for M&V analytics. This capability can be used to quickly verify other applications that use the data. PowerHawk Manager can generate the rates and tariff engine for billing, including coincident demand calculation for apportioning demand charges among multiple tenants. This is what the rating engine looks like at a high level, with common rates on the right, draggable onto any point of the meter network on the left. Each meter point can have a unique tariff definition. The PowerHawk Manager, as described before, can generate installation records based on meter configurations, service assignments, and panel association. We have previously seen that this is an important installation tool, removing causes of errors and providing a hard-coded correlation to the panel. PowerHawk Manager emails or FTPs reports for energy consumption and billing for external use by any third-party application. It is typical that billing information is driven by a property manager's financial package or the submeterer financial package. The PowerHawk Manager can forward straight usage information or fee-applied information for multiple meter points in a selected tree to generate monthly bills. So, summarizing the key advantages the Triacta PowerHawk platform and its cloud-based approach offers, especially to long-term partners such as service providers and value-added resellers that would like to offer higher touch, sticky post-installation services to their customers. Independent repository. Using the PowerHawk Manager to act as an independent data repository for customers to guarantee a lock-in free relationship. Customers are becoming highly attuned to openness and highly suspicious of solutions that lock them in permanently to a vendor. Locking can happen when proprietary standards are used, when the service provider acquires and holds the customer data. This is why Triacta pushes compliance with standards, non-proprietary communications, and guarantees that the customer owns their data, even if it resides on the PowerHawk Manager servers. This is an attractive approach for the customer. Complement, not replace. The PowerHawk Manager can be used to complement other service applications, not displacing them, focusing on the meter-specific features and allowing partners to deliver their own niche expertise in concert. Regulatory compliance. Perhaps one of the most important aspects of a meter to be used for either billing customers or conforming to building regulations is the use of a meter that complies with industry standards. This is also important for any application that requires any kind of traceability or benchmarking. When using meters for these purposes, regulators have either already specified that the meter should comply with certain specifications or will likely do so in the near future. It is a newer requirement which you do not want to run offside on. When money changes hands based on the information generated by a meter, then the regulator and the service provider have a responsibility to ensure that the data will be accurate, reliable, and traceable over a broad range of environmental conditions that typically apply in the expected use case of the device. Triacta has been operating in this mode since its inception 13 years ago, and its meters have always been designed to comply with the most stringent regulatory regimes. PowerHawk meters have been designed to fully meet ANSI standard C12.20 Class 0.5 accuracy and approved by California Department of Food and Agriculture, Measurement Canada, and the Philippines Energy Regulatory Commission, among others. Demand this of your meters. It will be a requirement in more applications down the road. We are at an inflection point in building management. where the requirement for a flexible metering platform is recognized as an indispensable tool for multiple stakeholders in the energy value chain. Triacta's PowerHawk platform has been designed to fit the technical requirements of metering, the requirements of easy deployment in both the new build and retrofit environment, and the requirements of being an enabling technology for partners to build value for themselves and their customers. Ultimately, I hope we've been able to show you that the time is now to fill the gap in the use of metering systems in the broader building fleet, and that there is a reliable and flexible platform approach that can help your company be a leader in this space. And that is the position that Triacta bases its entire approach to the market, as a partnering platform.